So the topic today is obviously smarter quality control for textile manufacturing. This is part of our series where we address different industries, how AI inspection can be applied to various industries. We did one in the roofing industry last month, um, if you got the chance to join that one. But we've picked textiles for this month, and textiles obviously being a high demand industry for AI inspection as it presents some unique challenges and has been conventionally quite challenging for automation in general and computer vision in general to inspect various textiles, and we'll dive into exactly why and the different approaches to that. So as Hannah said just now, we do want you guys to submit questions during the webinar if you have any, and we'll address them as we go, or get to them at the end if we miss any. But yeah, if you find the activities button, you can submit questions, and we'll answer as we go. But as we kick off every webinar, we always start with the promise and reality of AI for quality control. And obviously, it sounds great to automate your quality inspection process. If you're stuck in manual inspection, the upside of implementing automation is very appealing and attractive. A lot of vendors advertise increased yield, reduced scrap, and all these statistics that sound really appealing to manufacturers. But in reality, if you ever try to deploy machine vision or any AI system, the reality kind of looks a bit more like this, and you get stuck in what we call research hell, where you are struggling to gather data. You're kind of left to put it all together yourself. You're left to annotate data yourself to pick up the correct defects on your products, and you kind of never make it to a scalable solution, and it never hits the actual production line where it's providing the value that you saw previously. And that's what brings us to textile manufacturing and textile industry specifically, where the production reality proves to be very challenging, as I said before, for AI-powered quality control or for general computer vision for quality control. And a lot of manufacturers are stuck in manual inspection purely because of the challenges it presents, particularly with the high number of variations of textiles. You have a long supply chain where a lot of handoffs and different suppliers are supplying your textiles, whether you're producing products from incoming textiles or producing the textiles themselves. You also have a lot of problems in textile manufacturing that make AI even more appealing because of the missed defects. Manual inspection obviously proves to be very challenging for quality inspectors, and in textile in particular, there's a high percentage of missed defects in quality inspection, and that obviously comes back to a lot of scrap, rework, customer claims, and inconsistencies in batches, and that's obviously not good from a manufacturing standpoint. And so we kind of look deep into the core challenges in textiles. As you can see here, like one of the major things, not only is there a high number of variations of products within textiles, like very subtle differences in colors, differences in weaves or textures. There's also high numbers of variations in defect types. And this proves to be a challenge to, one, classify the defect types, is a whole other step beyond just detecting the defects in your textile products. And so this is really like the core challenge of textiles. And as I said before, textile industry proves to be an industry where a lot of defects are missed by manual inspection. And so like overcoming that is something that is obviously a priority for many manufacturers. And I pulled out these two images just as an example of one of the core challenges in the industry. You can imagine being a quality inspector in working with textiles or working with different weaves or different patterns. If you're staring at this type of product for 8 hours a day, trying to watch for defects, you can imagine why inspectors are missing a lot of defects. This is very straining on your inspectors. It's very hard on the eyes. It's hard to even look at this just on the slide for 5 minutes, let alone 8 hours in a day. And so consistency is something that proves to be a major problem with textiles. And like the consistency in individual workers and consistencies across different shifts is something that remains a problem. And another major part that proves to be particularly relevant in the textile industry is this whole defect consensus problem. And that, as I said before, you can have a number of suppliers supplying the same type of material or supplying the same product, and different suppliers are inspecting differently. Like just as you might find in one facility where there's a number of quality workers, each worker might inspect a product differently and classify defects differently or pick up on different defects per worker. It's the same with different suppliers. You come across this where you're fighting with suppliers or end customers on what exactly is a defect, or they might pick something up that you thought is not a defect at all. And AI can kind of provide this central control where you can say, okay, we've standardized the inspection process, and we're classifying a defect this way, and you get this consensus among suppliers or along the supply chain where you're all in agreement of what classifies as a defect or how it should be measured. And that can kind of be the mediator between different stages of the supply chain. This is like a particular problem that we came across in another industry, but in composites, where we've worked with bubbles was always a good example. Like where does it start and where does it stop? How to measure those, because if you have specific tolerances where you maybe say it's allowed to be less than 0.4 millimeters, but anything above 0.4 or 0.5 millimeters is classified as a defect. That might be measured inconsistently at different stages or by different inspectors. And so that's where a lot of the escape rates come from and escape defects come from. And obviously that's not something you want. And we've spoken with a manufacturer recently, actually, and it was quite an interesting case. I think a lot of textile, as I said before, is stuck in manual inspection. And while AI typically is seen as something that can help at this stage, if you look at the whole process, you might find opportunity to enhance and improve your process. Like here, for example, what this manufacturer was doing is they were receiving a number of rolls of fabric from different suppliers that need to go into their production process, and they were receiving these rolls and cutting patches from each of the rolls and laying these patches out on a table alongside what they call their golden sample, and their inspectors were manually comparing these colors, each individual patch to the golden sample to see if the colors match and if they think it matches. And this is obviously a very slow, time-consuming process to cut patches from every single roll, lay them out, and then for a worker to stare at, like, say, 20 patches that are extremely similar in color, and try compare them one by one to the golden sample is something that's not ideal. And record keeping was then manual as well, or they were literally storing these patches as records from different suppliers in their facility, and that just shows how um, a lot of manual processes are done, not just in inspection, but all these different approaches just to get the inspection done, where you're cutting different pieces, or you're trying to deal with rolls of fabric and laying out rolls of fabric. It proves to be, it compounds in terms of slowing down your inspection rates and also reducing errors in your inspection. And just as an example of the multiple different ways you can approach this type of inspection, you can go with the, like, mimicking exactly what they're doing, which doesn't cut out the patch cutting or cutting out specific patches, but it still reduces strain. So this approach here is reducing these two stages of the inspection process, where you no longer have to strain and compare, and you're getting extremely consistent color inspection every time you inspect, and it's not biased. It's obviously hard coded into the system so that you get accurate comparisons every single time, and you're using stuff like HSV values and RGB values straight out of the computer, with a calibrated camera or sensor, like a color sensor, to do that inspection for you. And that record keeping is obviously done with reports produced in the system. So you don't need to be storing that manually. That can be linked however you want it to be, whether it has a product code or a supplier code. Can be grouped by supplier, by product type, however you want it to kind of be stored in the system. The approach that we found was very interesting with these new handheld devices, well, not new, they've been around for quite a while, but integrating that with a sophisticated inspection software or quality control software, you can kind of really speed up this process. So here we're eliminating this time-consuming patch cutting and tackling these two steps or these two phases of inspection at the same time. And this is all stored in the platform itself, and you kind of can start getting analytics over time as well, per supplier or per product type, or, as I said before, however you want to group it. But essentially, in textile manufacturing, I mentioned before that conventional AI approaches or computer vision approaches kind of struggle, and this is common in quite a few industries, but textiles in particular, for the reasons I've given earlier, where there's high numbers of variations, both in color, in patterns, different types of weaves, different types of materials, different types of textures. Traditional methods fail because you simply can't collect enough data and train inspection models in time to keep up with production lines or keep up with the variations that are coming through. And you kind of, if you're given a solution where you have to put it all together yourself, you kind of get stuck, because it becomes your responsibility to collect the data for a given defect type, or and you have to annotate that data yourself. So most solutions end up stalling at this 80% mark, and what that essentially means is that it's pretty easy to get here, because you can kind of make do with very simple annotations, with very simple data collection, and get away with maybe some readily available data sets, or a vendor might offer you a specific platform that is tailored to a specific type of material or specific type of inspection of a certain defect type. And that can work, but when your production line is evolving, or you introducing new products, or you want to inspect new defect types, you get stuck. You get stuck at this point, and you end up just having to start again each time you want to inspect a new product. And as a manufacturer, obviously, that's not ideal for you, where you need reliable inspection, evolving with your line, and obviously adapting to whatever defect types or products you're presenting to the inspection system. And that's what drives us to synthetic data as the unlock that could show a lot of promise and potential with textiles, and has shown a lot of potential with textiles, simply because it helps curate data sets, and you don't have to do that data collection and annotation of data to train your AI models. And where synthetic data shines, which is particularly relevant for textiles, is in these three areas where there's limited data available, non-uniform or noisy products, and high numbers of variations. I think for textiles, you're going to find that these two categories here are most relevant. And as I said before, that's like high numbers of variations is obviously pretty intuitive for textiles. That's easily understandable. And it's non-uniform or noisy products. Some people struggle to understand this a bit, but you can think of something like a computer chip or like a PCB that you're manufacturing, where every product that comes through is exactly the same. There's no each component on the chip is in the exact same position. It has to be 100% the same every time, and every product that comes through is in the exact same position. That is something that conventional approaches are really good at, because once you've collected the data, obviously you know the product's never going to change. Every product's going to be the same. It's easy with even conventional computer vision approaches, where you're doing image processing procedurally, you can start picking up defects. But in textiles, because of the nature of the texture of the product and this kind of organic feel to the product, like a weave texture, not every product, like the weave is not going to be in the exact same position for every given product. Also, the elasticity of the product, or the that softness of the fabric, that can put the product in a different position every time it comes through the inspection station, and that proves to be particularly challenging. And so collecting data for that proves to be a challenge, because you can't account for all these subtle variations in the product. And so conventional systems might fail because they're struggling to recognize exactly what's considered good and what's considered bad when it comes to inspecting the products for defects. And to illustrate what synthetic data looks like and what I mean by synthetic data, I'll go through a product that we've launched recently, which is called ZELIA. And ZELIA is kind of streamlining this data curation and inspection model training flow. So we call it our end-to-end learning and inspection assistant. And this is something that can take the full end-to-end data curation and inspection model training process down from months to less than 24 hours for a given defect type or a given product. And this platform kind of gives you an idea of how synthetic data works and what it looks like. And as you can see here, let's say you want to inspect a particular textile for a whole defect or a cut or something like that. You might upload, say, a couple examples of that defect type. here being 5 examples. These are all the same defect type. It's on the same product surface. So you would upload that and just outline what you're actually looking for. You might say this looks a bit like annotations or labeling your data, but this is obviously only for 5 given samples, whereas in curating traditional data sets, you're going through hundreds of samples of a given defect type. So this is significantly reducing the time. So once you've uploaded this and highlighted what you're actually looking out for, the system will then go through and understand the defect type and curate a data set for you on that given defect type. So then you can train your inspection model. And so you can see here, this is a fully annotated inspection data set that is ready to go and train an inspection model for that given whole defect type. And once you've trained the model, you can then test it and see that it's picking up the defect type really well, and it's really accurate in inspection. And that streamlines the process and helps train the inspection model a lot quicker than conventional approaches. But obviously, just this platform, if you're a manufacturer who doesn't have hardware set up, or you don't have an inspection station set up, you have nowhere to deploy this, right? So that's where our service model comes in, where we offer an all-in-one inspection platform. So where we're doing the synthetic data on the back end to train the inspection model, we will also look at your case. We will understand what you're trying to inspect, and we have a fully curated inspection platform, quality control platform, that does the inspection tasks. It outputs custom reporting. It offers statistics and real-time data, so you can see exactly what's happening on your production line, or like throughout your facility and throughout the different inspection stations that might be deployed in your facility. And this can be configured to align with your standards and your rules. So if you're looking for particular defect types that have particular tolerances, that can all be configured on the platform to ensure the inspection is to your standards and meets your existing processes. And as I said, all results go to a live dashboard and output in a reporting format that matches your existing process. So you might also need something like a defect map to understand exactly where defects appear on your products, or if it's something like pattern matching on textiles, you might need to know exactly where or which pattern, or where it's misaligned or not quite up to standard. That all gets included in the platform to inspect the various products. And in our service model, we're handling the hard part. So we take on the challenge, and you can think of us as your embedded AI team. So we essentially take on the AI training. We take on the data preparation and curation that I spoke about before, and we configure the platform for you and simply help you deploy it on your line. And all you have to worry about is your product onboarding. So if you want to onboard a new product as your production line evolves, you'll simply onboard that new product, and you configure your reports by adding different defect types or tolerances on the platform to allow the inspection to match that criteria. And something that's very interesting and very relevant, as I said, in textile manufacturing, there's a lot of handoffs of products, and they go either inspected at multiple stations, or there's a lot of different stages in producing products with textiles. So having multiple inspection stations throughout your production process is something that can prove to be very beneficial, as you might find that where a particular defect type is spotted at station A that you might not consider to be a defect, always turns out to be a defect at station B. And once you understand that relationship, you can stop producing or adding more resources to a given product at station A, and that will obviously save you a lot of time and resources in your production process, and prevent waste, prevent scrap from escaping the line. And simply how we get started with you, if you are interested in doing AI inspection or interested in simply automating some sort of inspection that you're finding challenging on your line or you're having problems with, we would obviously hop on a discovery call, and we're happy to take some samples from you, whether that's physical samples or just some images, where you outline what kind of defects you're looking for on what kind of products, and you give us an overview of your existing process, how that looks, so we can understand how to configure our system and our approach to fit your process. So once we have that, we can give you a full proof of concept and an ROI estimate, and just prove to you that your challenge is doable, and then we would go from there to deploy a pilot system in your actual facility, where you can trial the platform live and see how it works. But yeah, I think I'll pause there for some questions, so we can leave some time for questions if you have any. We'll just watch the Q&A section. Yeah, shoot through some questions if you do have. In the bottom right, you'll see the meeting tools block, and there's a Q&A button once you're in there, and we'll happily answer any questions you have. Yeah, so I see one question saying there are many variants in our fabrics, like color patterns. Is it still suitable? Yes, it's definitely suitable. So that's exactly where the adaptability that we gain. So like I said here, high numbers of variations. That can mean lots of variance in colors. It can mean lots of variance in, say, sizes, or lots of variance in patterns or textures. Whatever the variation may be, it just requires an onboarding process for each different variant. But as I said before, that onboarding process is a lot quicker with our approach because of the synthetic data approach. So where traditionally that might take a few weeks for a given variant to onboard to a system that can handle inspection reliably, we've reduced that significantly by leaning into this whole synthetic data approach. onboarding with synthetic data. Okay, well, if no other questions are coming through for now, oh, there's one more. So for synthetic data, you you don't really need to worry exactly the technical details of how it works. What synthetic data unlocks is the time saving value for you. So with other vendors that don't utilize synthetic data and where the implementation of the solution is kind of given to you, like they just give you the hardware and the platform and you have to configure everything yourself, then of course you have to worry about the synthetic data step and how that exactly works. What we're trying to illustrate here is that you can have the option to do the synthetic data step yourself, where you are interacting with this new platform, ZELIA, and you're uploading samples and generating data sets. But this is suitable if you have an AI team or you have an automation team where you already have existing hardware and you are simply training new inspection models to handle a new variant and need some way to gather data or curate data and train those models. This technology, though, is what we can utilize in our service approach to streamline that process. And this is simply showing you how that works so that you understand why exactly it's quicker and still reliable. So this is just to give you an overview of how we manage the variations of products and how we scale with your production line.